Be sure your name, date, class period is in the top right-hand corner. The title of this note is Graphing the 6 trig functions. You're going to be able to graph all 6 trig functions, and you're going to find intervals on which the inverse trig functions exist. So the first type of functions, and you studied these extensively in Algebra 2, is graphing sine and cosine. These are called sinusoidals because they go up and down, over and over and over. So we have this parent function, y equals a sine bx plus c plus d. Now in Algebra 2, you focused a lot on the a, the c, and the d. And what's new to us is the b. So remember that a is the amplitude, c is your phase shift. Remember, you go in the opposite direction. So if it says plus, you actually go left. If it says minus, you actually go right. D is your vertical shift. And B is going to change the period. So the way I remember this is anything in parentheses deals with my x-axis, which is my period and my phase. Anything outside the parentheses deals with the y-axis, which will be my amplitude going up and down, and my vertical shift going up and down. The other thing that I use to remember this is anything in the parentheses acts backwards. So this plus sign actually means to go left, and likewise, if b is a big number, my period is going to get smaller. If b is a small number, a fraction between 0 and 1, it's actually going to make the period get larger. So b and c always go the opposite of what you would expect. So the steps for graphing sine and cosine. First, you want to find your amplitude. Then you're going to find your period. The period of the parent function is 2 pi, so you're going to divide that by b to get your new period. And then your phase shift, and you have to be careful, it's not just c, it's c over b. Because what's really happening here is I'm going to take my function, I'm just rewriting that, and I'm actually going to factor out the b. And when I factor out a b, I'm dividing b from both terms. So I'm getting x plus c over b. So my phase shift is actually c over b, and remember, it's the opposite of what you expect. That's why that minus sign is there. So once you've got these 3 features, it's a good idea to go ahead and graph a quick sketch here, sketch it over several periods, and then it's helpful to save your vertical shift, d, for the end. Now, there's no hard and fast rule. If you have a different order that works for you, that's okay. But this is a method that will get you there every single time. So after sine and cosine, we have tangent. So this is the parent function, y equals tangent x. And what I want you to notice is where the x-intercepts occur. We have negative 2 pi, pi, 0, 1 pi, 2 pi, 3 pi, 4 pi, and so on and so on. So your x-intercepts are happening at multiples of pi. And then in between each x-intercept, you have a vertical asymptote. That's these blue dashed lines. So in between 0 pi and pi, this is 1 pi over 2. Between 1 pi and 2 pi, we have 3 pi over 2. So these are happening at what we call the odd multiples of pi over 2. So any odd number times pi over 2 is going to be a vertical asymptote. Any odd number. Right, any odd number times pi over 2 is going to have a vertical asymptote. Related to tangent of x is the graph of y equals cotangent of x. So here's the parent of cotangent. And what I want you to notice is that the x-intercept and the vertical asymptotes are just flipped around. So this time, instead of having x-intercepts at pi, we have vertical asymptotes at pi. So here we have 1 pi, 2 pi, 0 pi, negative 1 pi, negative 2 pi. And then in between, at the odd multiples of pi over 2, that's where our x-intercepts are. 3 pi over 2, 1 pi over 2. Any odd multiple. And then the main difference, other than flipping the x-intercepts and your vertical asymptotes, is that tangent is going up to the right, cotangent is going down to the right. The next graph we have is y equals secant x. It is the graph in red. The way to graph secant x is to graph what is called a guide function, and the guide function is cosine x. And that's done here in green. So we've sketched cosine x. And then at every x-intercept, there's going to be a vertical asymptote. So here's an x-intercept of the guide. All these x-intercepts are going to turn into asymptotes. And then once you have your asymptotes, what you're going to do is you're going to take every maximum and minimum value, and it's going to become the vertex of a little parabola that's bounded by the asymptotes. Every max and min is going to make a parabola that's bounded by the asymptotes. And if you want to go back and erase your guide function, you can. So I'm going to add that in. We're going to sketch y equals secant. Every max min becomes a vertex of a parabola. And so secant x is just a bunch of parabolas over and over and over. So the last of the 6 trig functions is cosecant x. It's very similar to secant. It's going to have the opposite guide function sine. You're going to start by graphing sine, and that's here in green. And then same exact steps. Every time you have an x-intercept, it's going to turn into a vertical asymptote. And then you're going to use the max or mins as vertices of your parabolas, which will be bounded by your vertical asymptotes. And that's the parent for cosecant. The last thing that I want to talk about in this set of notes is the inverse trig functions. So what you have to be able to do is tell me where the inverse exists. So remember that the inverse exists if you pass the horizontal line test, because you're a function if you pass the vertical line test. Functions pass the vertical line test. So inverses, remember inverses switch x and y, so we're going to switch vertical out for horizontal. So I'm going to draw a horizontal line, and I'm going to see that it fails the horizontal line test because it crosses twice. So what you're going to do is you're going to create an interval that passes the horizontal line test. So example here, I can go from pi to 2 pi. So if you focus just on this green box, you'll see that every horizontal line I draw in the green box passes the horizontal line test. So one interval that passes is from pi to 2 pi. Let me try another interval. What if we do the interval between 2 asymptotes? Look in that green box. And oops, it fails. So this interval doesn't work. So your job is to create intervals where it does pass the horizontal line test. So how about from negative pi to 0? I'm just drawing some horizontal lines to check, and yep, it's passing from negative pi to 0. Let's see if I can find another one. How about in between these two that I have? From 0 to pi. And I say, yep, passing my horizontal line test everywhere. You should see a pattern in your answers, and so I'm noticing that it's multiples of pi, right? Here's 1 pi, 2 pi, negative 1, 0, 0, 1. So I could extend this pattern. It's going to work from 2 pi to 3 pi, 3 pi to 4 pi, 4 pi to 5 pi, 6 pi to 7 pi, if I had to make up ones. Even though I can't see the graph, my intervals will follow that pattern. That is it for our trig function notes. Go ahead and draw your line and bring your notes into class.